Hey guys, okay, so we're still in chapter 7 in Jacob's Algebra, and we are working on simultaneous equations. And in lesson 1, we learned that if we add them together to eliminate one of the variables, we can solve for both the variables at that point and check our work. So today, they're just adding, instead of addition, subtracting both those equations. Now remember, both equations are linear, meaning they form a line on a line graph. And so they're simultaneous in that they have a relationship that they're going to cross at some coordinate. That's what we're finding. So let's start with the visual. So the first one, we have 4 of some number, and we have 3 of another. So we'll plug that in. Let's say we have 4 clone troopers, and they each weigh a certain amount of weight, because they're clones, they weigh exactly the same, and they have 3 guns. I don't know what's going to happen to one of them, at a certain weight, and the total weight down at the bottom is 57. Our next equation, we have the same 4 clone troopers, and there were budget cuts, and so now they only have 1 gun. Don't know how they're going to manage that, but that comes to 43 pounds. So now we are ready to manipulate our equation. Okay, so we line them up, and now we're ready to subtract. 4x, take away 4x, leaves us nothing, and 3y, take away the unstated 1y, leaves us with 2y, and 57 minus 43 leaves us with 14. We divide 2 from both sides to get y all by its little lonesome, so y equals 7. So let's go up and start our coordinates. X is the first one, and we don't know it yet, and y is the second. See if I can make that 7 a little better. Okay, so now we are ready to solve for x. So we're just plugging y into one of the equations to solve for x. I just chose the top one. So 4x plus 3 times 7 is 21 equals 57. Okay, we've got to get x by itself, so let's subtract 21 to both sides. And we get, on the right side, 36. And we bring down our 4x. And 4 times x, the opposite of multiplication, is division. So we'll divide both sides by 4. And x is equal to 9. So we will go up here and put our x, which is 9. Now, we're not done because it's very important we know the weights of these things. So what we'll do is plug both of them into both equations and make sure that both sides of the equations come up equal. And so when you do that, you will find that 57 equals 57, 43 equals 43. Yay, we did it. Okay, then the rest of the practice problems really just set up an equation, the simultaneous equations, and they say, hey, subtract it. So that's what we'll do. Okay, so that gets eliminated. And remember that that's an unstated 1, so that leaves you with 4y equals, and now you've got to subtract on the other side, and that gets you 28. And we divide by 4 on both sides, so now we know y equals 7. So now we'll plug it in. X we're not sure about just yet. So now we only have one variable unknown, and so we can pick either equation and solve for x. Okay, so I picked the bottom equation, we have 2x plus, and I'm going to get rid of my y and replace it with the value 7. And now I'm ready to get x by itself on the right side of the equation. So I'm going to subtract by 7 on both sides, which leaves me with 6 on that side and 2x on the other. Divide both sides by 2, and x is equal to 3. And so we'll come up and put it up in our coordinate. And so now we know that both lines, this first line and the second line, given a graph, we know that it will meet up in a plus quadrant at the segment of 3, or the coordinate of 3, 7. We plot that out, and we will find that that's where, let's just say, let me erase this. We'll do an approximate. And so somewhere, that's where those two lines will meet. Okay, let's do one more. We're going to subtract. That gives us 7x and negative y minus a negative y. So negative y plus a negative y cancels, or plus a plus y cancels it out. So, and negative 20 minus 8 is just like saying negative 20 plus a negative 8. And so we have negative 28. So the only thing tricky about this is you really have to remember your rules with negative integers. Divide both sides by 7, and x is equal to 4. So now we build our coordinate. We know x. We need to solve for y by plugging x into one of the equations. The only thing tricky is just to be careful with your positives and negatives. So I've plugged our x value 4 into the equation. Subtract 4 from both sides. Negative y is equal to 4. Now, we can't have that negative sitting over there, and we have to remember that that's just like saying there's a negative 1 hanging out there. So we'll divide each side by negative 1. What is that? There we go. And this will make this side a negative 4. So y is equal to negative 4. Okay, whoa, I had to back up. So remember how I told you, be careful about your negatives? Yeah, well, I wasn't. So we forgot that 7 into negative 28, so we've got to throw that negative up there. And what will happen if you follow through everything and work out, once you have both the values and put them in the equation, if you miss that, your equation, both sides of the equation will not equal. And then you'll know, and the first thing I would check are those positive and negative integers and see if that's where we went wrong. Okay, so now that we have that right, let's put it into the equation correctly. That would be lovely. And our original equation was 8 on the right-hand side of the equation. All right, so now we're ready to solve. And instead of subtracting 4, we add 4 to both sides because that 4 is really a negative. And I'm going to go ahead and put my negative 1y equals 12. Divide both sides by the negative, which makes 12 become a negative, because when you're dividing a negative number into a positive number, it always is negative. So we are negative 12 with y. So we'll plug that in. Negative 12. So our coordinates are negative 4 and negative 12, and we know that the negative in the negative quadrant is over here, so our lines are going to meet down in the third quadrant. And we'll double check to make sure. We'll plug x, negative 4, and y, negative 12 into both equations and make sure that both sides of the equation are equal. And so I'll let you do that, and you'll find that, yes, we did it. So just remember, it's really easy, especially when you're kind of on autopilot. You've got to watch those positives or negatives, or they put you in a world of hurt. But the nice thing about simultaneous equations is you can self-check when you go to the last step and plug both the variables in, and you'll discover if you were a winner or if you went wrong somewhere and have to go back and redo like I did. Hope that helps with your homework, and I will see you guys next week. Bye.